Hello, this is Carlton Doe from IBM, and welcome to the IBM Informix 1410 Containers and Modernization Webcast, sponsored by the IIUG. I will now turn this over to David Link from the IIUG Board of Directors to kick the event off.
All right, thank you. Welcome, everybody. I want to thank you for taking some time and joining us for this webcast. I hope you get lots of wealth of information from this. I wanted to share a few updates as far as what the Board of Directors has been doing for IIUG. One of the things that we've recently done is we had everybody fill out a survey, and we've presented the results of that survey onto IBM and working with them on the results of that. The other thing that we've been doing is we've been missing you guys. We're a tight-knit group, and we all enjoy seeing and interacting and networking with each other. And I know we've been doing that online and such, but we're hoping that next year we can have a better situation so that we can go back to what we would consider our norm. Now, one thing that Carlton had asked me is if you have questions, again, he'd like you to ask them at the end. They'll open up the channel and for audio questions. Or if during the session, if you have questions, you can go into the chat. There is a chat button that you can click, and if you do so, there is a send to, and what you need to do is click send to all panelists. That's going to allow everybody to see the questions, and then they can get addressed either in live time or be followed up at the end. Appreciate if you could ask questions, be interactive with this. Your questions are going to be what other people may be asking, and since this will be recorded, they may leverage what the information that you're needing. So again, as a board member for the IIUG, I want to thank you for joining, and I'll turn it back over to Carlton.
Okay, thank you, David. I'm going to go ahead now, and Scott Pickett is first presenter, so let me make Scott here the presenter.
Welcome, everybody. My name is Scott Pickett, and Worldwide Informix Technical Sales, and today we're going to talk a little bit about CloudPak for data, along with the environment that it's going to go into. This is IBM's newest venture into the world of cloud, and I hope you'll find it rather interesting to hear about. So this is strictly about Informix CloudPak for data. It does not go into anything else, including how to install CloudPak for data itself. And it also applies exclusively to CloudPak for data and does not include any matter that involves data Informix on-prem. I want to make that very clear up front. This is our agenda, what we're doing. We'll talk a little bit about Informix containers, CloudPak for data with the additions and packaging, and the CloudPak for data use cases involving Informix and other services that IBM has in its CloudPak for data portfolio. Some terminologies first. Some of you may not be familiar with this. So basically, we're going to talk a lot about containers, and a container is nothing more than a method for a developer to package up an app with all the parts, libraries, and dependencies, and ship the whole thing out as a single package. Typically, Docker is the most common container and popular, which we also have Kubernetes containers for IBM, which we're going to talk about. Container differs a little bit from virtual images in that we're not containing two separate operating systems involving the container. For example, we know about virtual machines in terms of virtual machine images in terms of having an operating system buried inside of the image and external running the basic resources for the image. The difference is here is we don't have the overhead that's involved here. Containers are more lightweight, they perform better, and the end result is it makes it easy to deploy and manage them. Kubernetes is an open source platform for the automating and deployment and scaling and management of these containerized applications. Happens to be the central component of CloudPak for data. The other vendors in our business are going full blast into this as well. Google, AWS, and Red Hat have our own versions of Kubernetes. In order to deploy, we have something called Helm charts. We'll talk about those in a second. They are the vehicle by which Kubernetes does its packaging of containers. Red Hat is the OpenShift platform that IBM has for using CloudPak for data and Kubernetes. It's an enterprise edition of Kubernetes is the OpenShift container platform. Containers can be a logical packaging mechanism, which applications are logically removed from the environment in which they actually run. One of the big benefits of them, you can send out a piece of what you're trying to do rather than the whole thing. You can isolate the app itself from the environment that it works in. It allows them to be deployed easily and consistently, regardless of whether the target environment is a private data center, the public cloud, or even a developer's personal laptop. Containerization provides clean separation of various different concerns within a corporation and its IT department. For example, developers can focus on their logic and dependencies, while IT operations can figure out how to focus on deployment and management of the applications without bothering with the application details, such as specific software versions and configurations that are specific to the app and the app only. The separation of the app from the environment that it's in leads to smaller sizes in the containers. These containers can run pretty much everywhere. Linux, Windows, Mac OS. They're portable and generally have low overhead. IBM supports Docker as well as Kubernetes, which leads to a high degree of portability as well. They support the isolation of CPU, memory, disk, and network at the OS level from the application. So it gives developers a sandbox view in development where they can play at the code isolation. Or in production where a single container can be used for the apps and another for the database. And yet still more containers for failover in case one or more of the original containers develop an issue. So a little bit on Helm charts for a moment. So it's a Kubernetes package and operations manager, and using a package manager called charts, Helm allows us to package Kubernetes releases into convenient zip.tgz files. Helm charts can contain any number of Kubernetes objects, all of which are deployed as part of the chart. A Helm chart will contain usually a degree of deployment and a service, but can also contain an ingress, a persistent volume claim, or any other Kubernetes-based object. Helm charts can be used in Kubernetes to deploy an app or one of the components of a much larger app. So we have a list of official Helm charts at GitHub, the link on the screen, and the charts can be installed as is or modified to suit your purpose. For example, you can modify a chart to install specific plugins or to use a custom Docker image. Helm charts have installation instructions in them to tell you exactly how to install whatever it is that you're trying to install in that exact moment. So there are different kinds of Informix containers that are supported in the marketplace. For a while now, we've had on Docker Hub the Informix Database Developer Edition and the Innovator C. As you all know, developers for dev test, and Innovator C is for smaller, production-ready applications and can be used in production. And it is available at no additional cost. Version of Informix in both cases. We also have the CloudPak for data with Enterprise Edition. And it's available now. It's the same on-prem version of Informix, but as part of CloudPak for data, there are no features or functionalities that are missing. And then there's the Red Hat Marketplace, certified standalone container coming soon in version 3.5, which is supposed to be out at the end of this year, or the very end of it, literally in December, late December. So this is the look at Informix on top of the entire platform. CloudPak for data. So at the bottom, you'll notice that we're allowing you to be in almost any cloud whatsoever at the infrastructure layer. Red Hat OpenShift allows us to leverage any kind of leading cloud that's in the marketplace today, a container platform that's enterprise for an innovative and fast deployment strategy. The Kubernetes layer allows us to speed the ability of enterprise data management software and data governance and analysis, for example. Data virtualization allows us in place to literally create queries across data sources, disparate data sources that are not the same database. It can be different databases in place without the need to move and shift the data to obtain an answer. A lot of this operation happens in memory. And a services ecosystem deploy literally 45 plus analytic services and templates from IBM and third parties, including application packages and database packages and sources. You can do things like System R. Can somebody mute, please? Thank you. System R, various databases in the marketplace in which we compete. For example, Oracle. For example, MongoDB. So there's a wide variety of things that we can work with here. CloudPak for data. This is the website. We go to get information, for example, as shown at the bottom of the screen, installation, registration, get started, the whole series of instructions as to how to do those various different operations. So the first release is presently what we're in. It's 3.01. As I said earlier, the next release is due 3.5 in late Q4. Licensing presently is VPC only, and there is a conversion ratio on that. And it's 70 PVU to 1 VPC. It comes in two 14.1 editions, Workgroup for CloudPak for data, for which the containerized version is not quite available just yet, and the Enterprise for CloudPak for data. In version 3.5, we're going to be able to take the standard licensing methodology that we use in version 14 of Informix on-prem and use any edition of Informix inside of a container on the cloud. So, for example, you'd be able to use Express Edition or Workgroup Edition, for example, using your license key. So it's a bit more flexible than that coming up. Look forward to, again, end of this quarter. The product features are exactly the same for Informix on-prem as they are in the CloudPak for data by edition system. So here's an idea about our enterprise-ready cloud software in the CloudPak. It comes with open source components in many cases, pre-integrated with common operational services and secure by design. Encryption, for example, is turned on. Container platform and operation services are there for Red Hat OpenShift. You do the logging, the monitoring, security, identity access management, all comes through the platform. And you can see the various different possible applications of it below. IBM Cloud or AWS, edge computing, private cloud, and basic on-prem. Capable of doing any and all mixes. IBM certified, will run anywhere. So these are some of the features in the CloudPaks that we are supporting. and for Informix as well. The team has a little bit of development they have to do still. So the last 4 on the list are available starting at version 3.5. So this is giving you an idea of the various different cloud configurations for the containers and what's going to be available. Personally, the certification of a Red Hat OS and integrated CPD fully available for all 3 categories. Informix on Docker has been around for a while, and in 3.5, Informix with a pre-built container Helm is available. So some use cases, which is what everybody's interested in. Dev test environments are obvious case. Package up of some or all of your application code, portability with or without the OS layer, source code, libraries, binaries, the operating system if need be, database and test data, send out to all developers and testers all over your organization. A really interesting case for this. You can also do self-healing, auto-detecting when services are down and restore them, using groups of containers or pods using persistent data storage volume. A component may go down, such as the wire listener within a pod, and the pod brings it back up. You can also get multiple containers working together, or pods working together, if you like, which are groups of containers. Failover when necessary according to the architecture employed so that there may be one scenario and 4 pods working in concert together and the system as a whole does stay up. With a backup pod for each pod used, or to use the term lightly, a backup for the application pod and one for the database pod. We have to distribute a fully tested application and related components. Inside a container for remote retail stores in a 2,000 store plus chain from a remote location for production purposes with persistent data storage. If it's a database, we want to keep the data from A to B, so it needs to be persistent data or volume. Use the data use option across data sources and application stacks through CloudPak for data services. In CloudPak for data, we refer to services as being any application or competing or internally used IBM products as services rather than products and applications. The naming convention more than anything else. Interoperability through common connectivity. In version 3.5, we're going to have one set of connectors for all applications and services. And that's going to spread gradually throughout the entire portfolio. One set of connectivity. Data exchange through virtualization, disparate databases and sources. Write a query across 4 different databases without lifting and shifting the data to get an answer. Artificial intelligence to find hidden data patterns and trends using Watson. Finally, data governance of hundreds of thousands of files and database objects. The where is my data question answered. And this is something that a lot of very big companies have a big problem with. CloudPak for data is going to be a very interesting way to look at the world because it opens up Informix databases to hundreds of different potential applications, including those outside of IBM, given the common connectivity framework that we're employing. So at this point, I want to turn it over to Jan Musil. He's our demo guru, longtime Informix user in the Czech Republic. Jan has a series of demos showing some of the features that I've indicated here today. And with that, I turn it over to Jan.
All yours.
Hello, I will share my screen. Okay, so I would like to show you the demonstration with real installation of Informix in my own CloudPak for data. So first of all, I would like to introduce what I will demonstrate. The first, I will demonstrate that if you integrated your databases in CloudPak for data, you can access your databases traditional by all classic tools. So I will demonstrate how to connect via DB access, how to connect via GDBC, how to connect via 4GL. I will touch also administration, which is possible also by Informix HQ tool. And as a second, let's say, dimension is enhancement, which is given by all other services which are in CloudPak for data and can work together with Informix. I will show you how to do data virtualization with different sources. So I will create data virtualization joining of sources DB2 and Informix. I will show you some dashboarding which is given by CloudPak of data. Some Jupyter Notebooks, very simple, which is first step to machine learning, and also, as Scott mentioned, some kind of Watson knowledge catalog. So I see this Informix integration to CloudPak as all-in-one, as this modern, as we have modern mobile phones. So the modernization from on-prem Informix to Informix with CloudPak is away from the classical old mobile phone to the modern smart phones, where also all-in-one. So let's go to my demonstration. For your information, I recorded all steps of the demonstration from my environment, not to meet some unexpected technical issues, and on the other side show you all possible what I can. So let's start with the recorded demonstration. Okay. So the first, when Informix is installed to CloudPak for data, you log on to CloudPak for data, and among all services which you can show from CloudPak for data, you see the services which are available and also the services as data sources. So you can see here that Informix here is installed and is enabled. So it means that Informix as a cartridge or extension is installed. It means available, and if it's enabled, there is also instance created. So we look to instances, and here we can see different instances from different data sources. We can see that we have some data virtualization, DB2, and also we have Informix instance running. If we will open it, the first information which we need is information about Informix server here, which gives us information where to connect. The other screen show us also the internal services which are running on which port, and how these ports are done as external. So all these interfaces are available, are exposed to these external ports. So if you want to reach Informix inside CloudPak for data, we are reaching by these services which are defined here. So if we go to detailed information and look to details, here are the most important information which we will need to connect Informix inside CloudPak for data. The most important part here is username to which we use to connect, and the password which is generated or can be changed and generated to access our Informix. Here is also JDBC connection string to the default database, which is created together with instance which is created during initializing of this extension. So the first task which we want to do is Informix connectivity first from DB access. So if you look to Informix SQL host file, which is located with DB access installation remotely from some remote location, we can see that we are using here Informix as a server name, which is defined here, and also IP address of the node where Informix port is running, and also port, which is also defined later. So if you look now from status to internals, we can see here that SQLi interface has this IP address and this port number, exactly what we give to Informix SQL host file for our DB access, ISQL, 4GL, etc. So now we can run DB access, and by running DB access tool, we need to know details about user and his password. As we discussed previously, username is published here in details, and password is also here in details. So when we run DB access, we can connect to Informix. We can use, in our case, user 1001 user, and password, which is here. So we can just copy password, and this password can be copied to our DB access tool. And now we can see that we are in. So we see all databases which we have in our CloudPak. So now we can run normally all SQL statements which we want to run from DB access against our Informix running in CloudPak for data. For example, this very simple one against stores database. So now we see that we successfully connect via DB access to CloudPak for data. The second classical approach or access to Informix is JDBC. I want to demonstrate this by DBViewer tool, which use JDBC connection to the databases. So the first, I will define driver manager, Informix driver manager. So here we can see that we have JDBC driver here, and we can see URL template to access our Informix via JDBC. We can see again that we have IP address of the node where Informix port is running, and port number via which we can access our Informix. So we create a new connection. We select our pre-prepared Informix connection, and just again we submit username, which is user1001, and the same password which we obtain from the same location as in case of DB access. When we copy paste, so we test the connection, so we connect it, and now, for example, in this tool we can retrieve again all databases, and also we can retrieve data from some table, for example, again from customer. So again, we retrieve the data from our Informix in CloudPak. Informix in CloudPak for data is also accessible via new administration tool, Informix HQ. So we can see that server and agent are online, and we can see that all capabilities of these tools is available also for Informix running in CloudPak. We can check performance. We can list all threads. We have also available Schema Manager. So again, we can connect to the database, run any type of SQL statement, and get the data. We can do different server administration tasks, and we can reach the spaces which are created persistently in this case, because pods are not persistent, but storages are created as a persistent, and we can do the backup. For example, here the backup level 0 by onbar. We can also see the logs, and also we can define different system reports. And here we can see that our Informix is running on Linux platform, because OpenShift as a platform, Kubernetes platform, is running on top of Red Hat platform. Worker nodes are running on Core OS, which is Dockerized Red Hat platform. Informix for GL. Informix for GL is possible also. The application is also possible to connect to CloudPak the similar way as previously. So as you see again, in this very simplified solution, we have again our username, we have password here in the open form, but normally in normal application the password will be asked to stay hidden, and we connect to stores database Informix as Informix server name of our Informix instance running CloudPak, username and password. So if we run or compile and run this application, we can again prove that everything is working. Here is very simple application to retrieve some data from customers table. So this stuff which we saw now is traditional classic access to the database, to Informix. So is a proof that if you moved your database to CloudPak for data, all your traditional applications should work still, even if you migrated your database to CloudPak. But it's not only what CloudPak is offering. CloudPak is offering the integration with other services which are part of CloudPak for data. The first service which I want to demonstrate is data virtualization. In my demonstration, I have one table, table orders in DB2 and table customers in Informix. And by this CloudPak data virtualization, I will join the data from these both different sources. And after creating of virtual view, I will use this view to create some simple graphical dashboarding of the results from this virtualized view. So let's continue with this. So in data virtualization, I select data virtualization, and if I select data virtualization, I can see data sources. The first what I will do, I will create a connection to Informix. I will select the type of the connection, Informix, and fill again the information to information which I am retrieving from detailed connection page here of Informix instance. So again, the password, type of the Informix on Informix server is Informix. I will test the connection, so I can see that my connection is working. I will create this connection. So now I will have two types of the connections for my demonstration. The first connection is to DB2 data source, is the first one. And the second is currently created connection to Informix. Now I want to do the data virtualization. I want to create the view from these two different sources to two different tables. So now when my data sources will appear, the first what I will do, I will run virtualization task. And in this virtualization task, I will select assets, in my case tables, which will be used to create my view, virtualized view. I will add customer table from Informix, and I created orders table in DB2, so I will take orders table from DB2 to the chart. And now I will do the virtualization of these two tables from different databases, different sources. So both tables are now virtualized, and now I will create the join. So I will select these two tables for the join. I will specify the key, join key for these two tables. As you can see, you can specify here also more complicated SQL statement by SQL editor, and you can also specify some filters for these virtualized joined tables. So now, in the next step, we can see the preview that really the data is retrieved from both sources. Now I will create the virtualized view. I will use some name, and I will store this view to some project. For example, Informix IFMX project. I store this view in the project, and after storing this view into project, I can reach this view from the project and work with this view, with this data by other, or use this view, this data by other services. So now I'm in the project. So during a few seconds, I will see that this view is among assets, and here is my virtualization view in the project. I can run the preview of the data from the project. I can do the profiling of the data, which we see later. And also, I have also the lineage, which is also required by the customer. Lineage means which steps are done with the asset, all steps or documentation of all steps which are done by the assets. So I can create a profile, and this profile also available or allows us to do refinery. So refinery means that I can, for example, discover the duplicates value. I can discover there are null values, if rows with null values can be deleted, or some null values can be replaced by non values, etc. So this refining. So here I can use pre-prepared operations or R language to do refining. Now I have this created virtual view. And in my project, where I created this virtual view, I add to this project dashboarding, which is other service part of CloudPak of data. This dashboarding is very simplified version of Cognos. So I can create a dashboard for visualization of our data. So I will create very simple visualization aggregation of the data using my virtualized join from two different databases. I will create a template, and now I will select the data source. The data source will be my assets. So my view, which I created previously. This is the view. I will select this view. In this dashboarding service, I will see all columns in this view. There are the columns from both sources. And very simply, by selecting, for example, ship chart and state, there is automatically decided which type of the graph will be used, because we have city here with some names, etc. It automatically selected is map. And because we have here ship chart, which is the number, it's automatically use this number for summary. So automatically was created the aggregation sum. So now by these two clicks without any programming, we have the chart maps where we have aggregated values for every state which we selected here. We can also use some filtering. So we move this state column, and we can select just only states which we are interested in here. We can also change the map. We have available some other maps. So for example, we will use pie chart, and immediately the result is reformatting to the new graphics, to the new dashboard. These dashboards can be saved and also here, and also used in read-only form by other users, where this read-only form allows you to change the filter or change the type of the graph. So now we are in pie chart. So we can change this to different type of the graph, for example, again to the map. So as you can see, we have the edit mode where we are constructing these charts, these dashboards, and we have read-only mode where we are able to work with these charts or dashboards. So it was dashboarding. Other is more deeper from programming perspective. CloudPak for Data contains also Watson Studio, which allows you to use Python language or R language, where you can, in Jupyter Notebooks, create your, for example, machine learning application or data science application. In this part of the demonstration, I want to show how very simply it's possible to connect to my database and how simply is this connection to the database implement to Jupyter Notebooks. So I have created connection to Informix again. So you can see, you see the known information. You can see again here host name, port number, server. So again, the same information. I'm using the stores database here. So we test the connection. Connection is successful. So I will use this connection to create my task in Notebook. So I will create Jupyter Notebook, which is part of Watson Studio. Jupyter Notebook is running with Python kernel. So now the kernel for this notebook is starting. And after the kernel is started, I need the connection to my Informix connection. So I will select the connections, use pandas, and the code for the connection for some table, for example, again, customer here, is automatically generated. So when we select it, we have immediately the example of the cell source code, Python source code, which is generated to connect my Informix connection. So we can see that the connection to Informix is successful. So now I can use the same connection for a little bit more complicated query. And with some graphics, I can again retrieve the data from Informix CloudPak for Data and do some visualization. And the last thing which I want to demonstrate is integrating with Watson Knowledge Catalog. The first thing which we can do from this organized point is data discovery. So data discovery allows us to discover the data which we have in the database, to do the classification of the columns, and based on business terms, for example, we can assign some predefined business terms for other analysis. As you saw, we again connected to our IFMX connection. We select orders table and related table, which means orders and customers table for the simplicity. We will select governance project, and we start discovering of the data. By discovering of the data for the related tables are analyzed. So first, the tables are imported. We can see that we have two tables, orders as customers. And after importing of the data is analyzing. So analysis is running. So we can go to the assets, so really customers and orders are discovered. We can see that the quality score is calculating, is in progressing, but we can see that data classes are, we return a little bit back. So we can see that classification of the data is done, yeah, here. So if we will continue, data discovering part will be shortly finished. And after finishing, we can look to final results. So we can see quality score for every table and for every column. And also, as you can see, based on some conditions or rules, policies defined for business terms, we have selected, for example, sensitive data. I have created one business term which assign the sensitive business term to the columns which contains, for example, sensitive data. In my case, first name, last name here. So if we will go for other, we can go now to our data governance project. And in data governance project, we have the dashboard which inform us about our results. So here is the project. And if we look to the project, we have the chart for data quality. We have the chart for relationships. We have information about data assets, data rules. We have the information about discovered relationships here and some others. If we go back, for example, here to top selected classes, for example, we can go to last name class, and we can see that the last name is a person name class, and now we skip to information governance catalog, where we have the information about class which was assigned to my last name, L name. Here is the rule which is implemented by CloudPak as a Java class. And all this information now are created or exported to governance catalog, where from governance catalog by business people can be retrieved, etc. So that's all from demonstration. Maybe we have a couple of minutes in the real time. One thing which I want to show you is, here is, it's not recorded, is the real environment. I am logged on to my cluster, and I will show you where Informix is running in the cluster. So we get all pods, grab Informix. So here are the pods running for Informix, and these pods contain our instance running. So we can go to this pod, and now we can run normal statement which we know on start db access on start -d from this pod. Interesting thing which we can see is where the data are stored, because pods are ephemeral, so-called. So if I restart pod, all information is lost if the data is not stored persistently. To be able to restart pod with Informix, we need to store our data persistently. So if we go here to ls-l opt IBM data. Okay, we can see that our IBM data is stored here in my NFS server. I'm using, for storing of persistent data, I'm using NFS storage. Portworx is other option in this version of CloudPak. I'm using NFS. So my NFS in this server is stored my data. So we can look to my NFS. So I will copy it, exit. It's my NFS server. And we can see really that I will go to my NFS server and list this directory, which is mounted to my pod to Informix. I really see all information which is stored here in Optim IBM data. So thank you for your attention. That's all from my demonstration.